Good morning, students. Today, I would like to continue the session. The previous session was a general organic chemistry, and we are continuing that only. And the previous sessions, we have discussed some of the basic fundamental things, and now we are continuing those topics, and we will go somewhat deep about those topics. And our chapter name is General Organic Chemistry, and today basically we will see in the chemistry we will see a lot of reactions. Basically, what is a reaction? A reaction is a conversion of reactants to products, right? Reactants will convert to the products by some driving force. The driving force might be some kind of intermolecular forces, or might be any kind of a force. So this is the conversions from reactants to products. This happens. We shall know a brief idea about what is a reactants. What are reactants? Basically, reactants consisting of two parts, that is substrate, and the second one is reagent. Substrate and reagent. Reagent means what? A reagent is a species which will attack on the substrate matlab the thing which is going to make product, which is substrate. So the reagent can be defined as a species which will attack the attacking species. You can simply write as attacking species or reagents. And the substrate, the molecule or a compound which is going to be attacked by the reagent, molecule or a compound which will be attacked by reagent. And in all the organic chemistry, we will see different kinds of reagents, and we will see how many types of reagents would be there in the chemistry. And let us see a few types. And basically, the reagents were divided or classified on two types, and two types of reagents would be there. And the first one is electrophiles, and the second one is nucleophile, and these things were very important for the reaction mechanisms. And let us see some of the characteristic features, what makes it electrophile and what is a nucleophile. Basically, let us see what is an electrophile. Let's see. Electrophile, first of all, it will be represented with the E plus symbol, and the first point needs to be strike in this one. This is an electron loving species, electrons loving species, and whereas nucleophiles are nucleus loving species. Nucleus loving species. So this is the point number one. And the point number two, this is electron deficient electron deficient. Electron deficient, where here simply we can remember this E plus. E plus matlab where plus indicates the deficiency of electrons in for example we will see in the cations. It's where it's the cations represent the deficiency of electrons in the metal, where here also the deficient species. So whereas in nucleophile. Nucleophile generally represents with Nu minus, and this is E plus. Nucleophile and electrophile. And nucleophile is a electron-rich species. Electron-rich or dense. Electron-rich or dense it consists. And for examples, we will see. For example, we can see some of the examples in the electrophiles, mostly Lewis acids are electrophiles. And what are Lewis acids? Lewis acids are which accept the pair of electrons, pair of electrons. For example, we will see H plus. H plus is consisting of no electron, so it will accept electron pair and it will make a bond with some other. Or some example we can see NO2 plus, and this is containing some deficiency in the electrons, and it will make a bond with some metal, so it will act as an electrophile. Whereas see, in the case of nucleophile is a electron rich species. It always wants to donate its electron pair to the deficient molecule. The deficient molecule is nothing but electrophile. So the reaction will happen between nucleophile and the electrophile. That electrophile will accept the electron pair from the nucleophile. So let us see some examples. Electron pair, for example, we can see NaH3 positive charge nahi hai. This is a lone pair of electrons, so it can act as it can donate this lone pair and it can access nucleophile. And the negative charge containing examples like carbanion like a C minus, or we can see some examples like a cyanide example, or cyanide is one of the best examples for the nucleophile. And let us see if we will go through the reactions, so we will understand the most conceptual theories of nucleophile and electrophile. And there are I would like to mention a few points regarding this. Electrophiles again have a different types, and the primary thing that we can learn from organic chemistry is, first of all, we need to identify the thing that is electrophile or a nucleophile in the reaction. And we will have different types of electrophiles, and this is again classified, and nucleophile also classified. Let us see those things. So electrophile is divided into two types. So for simplicity, I'm writing electrophile as a E plus. E plus is divided into two types, and the first one is, this is charge containing and these are neutral. Species. Neutral species also will act. So for example, I will show how it will happens. For example, a charge containing species H plus H plus containing some charge, positive charge, and R plus. R plus is a charge containing, and Br plus. So many examples for the charge containing. And diazonium salt we will see in the Sandmeyer's reactions. And let us see how this N2 plus. This is diazonium salt, and acetylene, that is CH3 and C double bond O and containing carbocation. This carbocations, and I have forgotten that carbocations are carbocations are reaction intermediates, but they act as electrophiles, and they are charge containing species. And let us see how a neutral compound can act as an electrophile. And electrophile is in the neutral case, for example, a molecule uh, containing vacant orbital, containing p orbital, p vacant orbital. So vacant orbital matlab, so it can accept the electron pair. Vacant matlab some space is there where electrons can be accommodated. So the deficiency of electrons is there in the vacant p orbital. So it can accept the pair of electrons. So it can act as an electrophile. For example, so you will understand if I give the examples. Let us see some examples. Some BF3 is a boron, so where p orbital is vacant, and you will see all BF3 or BBr3, BCl3, uh, BBr3, and these are all vacant p orbitals. And even if it is a vacant in p orbital and there is a containing vacancy in d orbital, also can act as an electrophile. So containing vacant d orbitals, d orbital vacant d orbital can act as an electrophile. So let us see the and okay, this is also I'll give some examples like ferric chloride, FeCl3 and FeCl2, and some transition metal salts. So this will act as a vacant, some vacant d orbital would be there. So those orbital will accept the pair of electrons and act as an electrophile. And third type, let us see. These are species having lone pair low lying orbital, anti-bonding molecular orbital. Let us see. I will explain you in detail these things. A species containing low lying sigma star anti-bonding molecular orbital, anti-bonding molecular orbital MO. And these, like actually we will see homo diatomic molecules like Br2. This is a I will explain you in the further sessions. It will come what is in a low lying what is low lying orbital and what is low lying anti-bonding sigma orbital, and these things I will discuss in the next class, because there it is I'll use, and is the time is also important. So in this session I'll concentrating on the basic fundamentals, and you no need to worry. I'll give you neat and clean lecture about everything. So and this is like this thing, and let us see. And fourth type of neutral electrophiles is like pi bond containing. For example, I'll give you a best example. When acetaldehyde, it is there, acetaldehyde. This is acetaldehyde. So when a Cn minus, this is Cn minus is a nucleophile. When nucleophile attack, so we know that oxygen is more electronegative than carbon, so it will have some partial negative charge, and some partial positive charge. So the negative charge of the nucleophile will attack on the partial positive charge of the carbon atom. So as a resultant of this, the pi bond between oxygen and carbon will shift to the oxygen atom. So there you will get an negative charge on oxygen. Here it's accepting like a pair of electrons from the nucleophile is accepting by the carbon atom. So here the carbon atom consisting a double bond with oxygen, an electronegative atom, more electronegative atom, it is transferring to that. So the carbon acting as a electrophile. So this is like this, the product, and this is like this. And these are the basic fundamentals required to understand, to identify the electrophile. And let us see, whereas in the nucleophile case, here we will see nucleophile. Nucleophile generally we represent with Nu minus, and this is classified into 4 types basically. And these 4 types are: first one, a negative charge containing species. A negative charge containing species, as we have seen, Cn minus is a negative charge containing species. So okay, and second type, and these are organometallic compounds. Sorry, my writing is little bit hard to understand. Hope you will understand, and I'll try to improve as well. Organometallic reagents. Organometallic reagents are nothing but, for example, RMGX. RMGX which is known as familiarly known as a Grignard reagent, and this is how you may get doubt like R plus and MgX minus. So this one will attack as a nucleophile. So this one will act as a nucleophile. So and this is for identification of nucleophile in the reactions. So basically, I am discussing when we go for the reaction mechanisms and how the reaction will take place. We will discuss in the further sessions. And first of all, for the basic fundamentals, we need to understand and we need to identify what is a nucleophile and what is which molecule is acting as a electrophile. These things we need to understand. And the third one is lone pair containing species. As I have seen, I have told you, given the example in the ammonia, and this is the best example. The lone pair is there. Or for example, water molecule is there. Water molecule also can act. It has a two lone pair of electrons on the oxygen atom, so it can donate. So electron dense molecule, so it is a nucleophile. And the third one is a pi bond containing species, and these pi bond containing species will act as a nucleophiles. That means the pi bond will be donated. For example, some H plus came, it will donate. So H2 palladium, for example, another thing will come, some reagent, but anyhow the pair of electrons will be donated to the atom. So this double bond containing will also act as a nucleophiles. And this is for up to the session nucleophiles, and electrophiles we have completed. Thank you for today's session, and next session will be some more interesting. And thank you.